Hey y'all, Data Guy here. And today, what I'm showing you on the screen right now is a dashboard that's actually reading from an analytical database that sits 2 seconds behind a production MySQL database with live sync, updates, deletes, all of it built in. And a year ago, that would have been the entire video, but now, if you look at the right side of the screen, it's actually not a person clicking around a dashboard. There's also an AI agent that's answering a question, and to do that, it's firing 36 SQL queries inside a tenth of a second. Every answer that we ask is coming back in under 100 milliseconds, and the agent is unblocked in 130. And agents are, now the heaviest users of databases, right? And they query in a way that humans never did. So being able to build for these types of use cases is really important, right? Because you need to be able to have these kind of constant updates being done by your agents. So without further ado, let's get into it. So today we're going to build this stack twice, right? First, I'm going to show you the manual way with open source parts, so you understand every piece. We'll have MySQL, Flink CDC with Apache Doris, and then the easy way where all that plumbing collapses, a warehouse that reads your production database's Binlog itself with one SQL statement standing in for an entire pipeline and a set of skills that let coding agents design and tune the warehouse for you. So now let's go over to the code and get started. So the problem statement for this use case is twofold, right? You have a production database and something that wants to read it hard, initially just dashboards and reports, but now agents as well. And if you point them at production, your checkout queries are going to be fighting full table scans, and it's just a recipe for disaster. But batch ETL, if you're trying to keep analytics and operations in sync, will keep it a day behind, right? So the fix is change data capture, where you tap the database's replication log and stream every insert, update, and delete into an engine built for analytical reads. And the engine here is Apache Doris. It's the open source project that VeloDB is built on. It's columnar, it speaks the entire MySQL wire protocol, and the part that really matters is that it's built for exactly the traffic that agents generate. A lot of concurrent queries, low tail latency, and heavy update streams that land all at the same time. So first, in part one, we're going to feed it with Flink CDC, the standard open source answer. And then in part two, we're going to use something that doesn't exist until Doris 4.1, the warehouse reading the bin log itself with no pipeline in between. And then we're going to hand the database over to an agent with VeloDB's agent skills for 2 roads, 1 warehouse, and 1 dashboard. Right, and the shape of everything is going to be, in order. It lands in MySQL. MySQL will then write it to its bin log, its replication log, and then in part one, Flink CDC will tail that bin log and batch changes into Doris about once a second over HTTP through a mechanism called Streamload. In part two, Doris will tail the same bin log itself through a built-in streaming job, and the middle of the diagram just goes away. So either way, seconds later, the row is queryable, and the dashboard and the agent bursts on the right side of the diagram never know or care which road it took, right? So part one is kind of going to be our first section, and then we'll do part two at the end and kind of adapt the base that part one was built on. So first, everything is going to start within a Docker Compose file over here. So we go and open up our Docker Compose.yaml file. You'll see this is going to have all of our services that we need to run here, because we want to be able to run this all locally, like everything we build in this channel. And I've organized it kind of top to bottom in the order that the data will be flowing. So first at the top we have MySQL, and the command block is the entire CDC story on the source side. So log bin turns the bin log on, bin log format row logs actual row values, and bin log row full logs complete rows. The last two aren't strictly required. Here we have row metadata full and get GTID mode on, but they're how production MySQL replicas actually run, and the repo's bonus CDC tool will want them. So if your production MySQL is replicas, you're probably already configured almost exactly like this. Then down here, we have Doris version 4.1. Make sure you're using at least 4.1 because that's the whole reason part 2 of this video exists and is possible. And within Doris, we have 2 containers. We have a front end, FE, the brains, query planning, and metadata. And then the back end is the muscle, the storage and execution. And then the official images will wire together through 2 environment variables here. And you both want fixed IP addresses as well for these 2 different services here. And then down here, if we go actually all the way down into our near the bottom of this, right, you'll see that the way we set these out is, Docker hands out addresses from the start of the subnet. So on my first boot, the container already taking the address Doris is pinned to, and if you refuse to start. So this IP range line will split the subnet where dynamic containers get the top half, but Doris keeps the bottom. So if you pin container IPs in compose, carve out the range. And then everything else in this file has a profiles key, which means it starts only when asked by name. And so I'll get back and kind of tell you about the rest of the services when we actually start using them in part 2. But right now, really just need to know around the Doris setup and the MySQL operational database that we'll be using for it. So next, let's start actually setting up that operational database by going into our MySQL folder over here. So this schema it's a fictional bike shop. If you've ever done like Mike's Bikes in college, very similar to that. And it's just going to be customers, products, orders, and there's nothing analytics flavored about it. It's the point of CDC, right? The app isn't changing. This is just an operational database. And then down here, we also have, go down to line 87 after we've inserted all of our data, you'll see we're actually creating a few users, three CDC users, one per pipeline that we're going to create in this video. And the grants are pretty small here. We just need select replication slave, replication client, plus reload, and that's all it's going to take to be able to read a binlog. And then also notice that the first two users here have identical grants, and file that away because it's a clue for part 2. And then also catch that MySQL native password, right? MySQL 8's default auth plugin wants TLS or a public key handshake, and a JDBC client will refuse it cold with a public key retrieval is not allowed. And I hit that error, you probably will as well. So every CDC tutorial is actually quietly using that native plugin, and now you know why. And then up here, really, this is just the kind of different data we're going to be using. I think the only thing interesting here is the heartbeat table. And this is one row where we have a simulator that's going to overwrite it every half second with a fresh UTC timestamp. The dashboard's later going to read that row back from Doris and subtract, and the result is the true end-to-end latency of the whole pipeline committed to a queryable table, and it's measured from the outside. So no component gets to grade its own homework, and because every pipeline in this video syncs this table, the same honest number is going to score at every part of this table and every part of this video as well equally. So next, the other thing we're going to do, and this is kind of the tax you pay in hard mode if you're not using the latest versions, is if we go into Flink in here in this Docker file, so setting up our Flink environment, right? So Flink needs a lot of assembly. The CDC distribution, the pipeline connectors, the MySQL JDBC driver, which is GPL license, so no Apache Project Level or bundlets. You're going to always need to add that jar yourself. And also, down here on lines 31 to 35, env job manager RPC address equals job manager. If you don't have this, the image's entry point will rewrite the job manager address to every container's own hostname. So the task manager tries to connect to itself forever, and the cluster will never form. So make sure you just kind of note this for later. So here, we're also going to need to set up the Flink config. So within this, you're going to want to make sure that you have one number that's really going to matter for latency, which is this execution checkpointing interval 3s. The MySQL source will ride the checkpointing cycle, right? So this is how we're going to be riding that. And then the pipeline here within Flink, MySQL to Doris, right? This is the payoff file, the whole pipeline, where we have a source block, a sync block, and a name. So we have our source, MySQL, we have our sync in Doris, and we have a pipeline that's just syncing this data, right? And then tables or demo dot slash dot star is a regex. So every table in the demo database, including ones that don't exist yet, and Flink CDC snapshots what's there, creates a matching Doris tables, then tails the binlog and updates and deletes flow, even an alter table flow. And also down on line 26 here, this sync buffer flush interval means default is 10 seconds, but this interval is most of our end-to-end latency budget, right? So when we run make CDC, 20 seconds later, tables we've never created exist in Doris with the snapshot already inside. So just really cool for showing this in a really fast demo. So now all I'm doing here is just running a make sim command from this make file, which is really just starting up all these services from the Docker file I just showed you. And then if I go back into my Google window, or Google Chrome window, you'll see I now have my dashboard up. So this is up and ready. It's simulating some traffic, right? So you're seeing the simulator actually work in real time. So here you can see it's lagging, sync, and you can see that happen live at the top of the screen which I personally think is really awesome for any kind of demo video. I always like showing something live. And so here we have 10 orders a second. A quarter of them are later promoted, are placed to paid to ship. So you're seeing them kind of go through that cycle. You have 3% that are canceled outright. And this is the demo that only inserts is hiding something. And the dashboard is polling Doris once a second with 7 real queries and printing each one measured milliseconds in the footer chips as well. You can see the ingestion latency. The latency tile is going to read about 2 seconds, and that's that heartbeat math from chapter 2 earlier. And also, if you watch the latest orders panel, right, status chips flip as updates land, and canceled orders don't get flagged; they vanish. And that's Doris's merge on write model applying CDC deletes for real, which is pretty sick that it's able to just do that automatically. And then backend wise, it's really just going to be one dictionary of SQL. So if we go into our app and then into our dashboard script here, you'll see that we just have a script. If we go down to line 40, right, where we have all the different Doris queries that we're running to generate those nice visualizations on our dashboard, just timed with a time.perf counter on every poll, right? And if we actually see in line 28 here, your Doris demo ID, the target DB, comes from a Doris DB environment variable, default demo, right? And this is our kind of cliffhanger for part 2. And so really for part 2, right, history doesn't come through CDC, it comes through Streamload, Doris's bulk API. So if we go into our scripts file here and go open up stream_interload.sh, what's happening here is, again, we're having history come in through Streamload, which is Doris's bulk API, and it's one just curl put against that endpoint for that Streamload. So the flag that most people miss will be -- location trusted here. And just make sure that you're including that in there because the FE redirects the upload to a BE, and curl must resend credentials. So 1,000,000 rows, 61 megabytes committed in about half a second. And make sure you're keeping this door in mind, right? Because Flink's connector walks through it about on every 1 second flush as we're running this pipeline. Now, next, we have it kind of getting a little spicy with the reframe that this whole video kind of hangs on. And for that, what we'll do is go back into that app folder into our, agent burst file. And so here, right, a human analyst, and this would be running a query, reading it, thinking, running another, right? An agent doesn't do work like that. It'll investigate one question, fan out dozens of statements at once, do point lookups, aggregates, joins, then block until the slowest one returns. And to the database, that's going to look like massive bursts, right? Many queries with start timestamps that are packed into the same second, where tail latency decides how fast your agent thinks. So this script is essentially simulating that. So here we have different query shapes. So each task is picking 36 different queries that we might be running within this database, right? That an agent would be running, the same shapes that an agent would generate, and firing them through a pool of 12 connections. So down here, and kind of just our different line, our code for actually setting out the bursts. Right, for every burst, it's going to report what the agent experiences, how tightly the starts were packed, the latency percentiles, the share under 100 milliseconds, and the number that will really matter, which is when the agent got unblocked. So next, if we go and run my kind of this simulation script, and you can just see, the end of this is really just running that with the given pool size and the amount of threads we want to use here, and running all those queries in parallel. So here, if we run make agent burst, right? What this will do is, on a laptop, right, while we're running this, we have 36 queries that are going to be packed within a 1/10 of a second. And now you can see actually these queries starting to appear within our dashboard. So now you can see every single one of those, even though they're happening, right, the latency isn't spiking. The agent wasn't blocked in about 130 milliseconds, and the ingestion latency still isn't moving, right? And then if I add sustained pressure with something like make storm, right, this will actually do 8 workers that are looping analytics queries, and the cluster will hold around 200 queries per second with 0 errors while the update stream keeps landing. So this is still running, right? You'll see it spike for a quick second, and then it goes right back down to that low latency. So even with massive amounts of concurrent reads on not a super powerful laptop, this isn't a top of the line MacBook, you've got low tail latency, even with really heavy updates, and that combination is the reason that this engine class exists, and it's the profile that agent traffic has, and that you now kind of need to think about building to handle, right? So That's the hard mode, and now you understand every layer of this video, but it also took us standing up a Flink cluster and connector jars and a networking war story and YAML dialect. So let's make it a lot easy with part 2, right? And showing off how you can do this with a lot of native CDC tools. So now, what if we could do all of that without the pipeline, right? So this is the reveal here. As of version 4.1, Doris can read the MySQL binlog itself. It doesn't need a connector that you deploy next to it. The warehouse is the CDC engine now. So this file on screen, if I go open up my scripts, and my native cdc.sql, right, you can see how we can actually enable the native CDC engine within Doris, right? It's just one SQL statement and it's the replacement for everything we did before with that pipeline, right? So kind of walking this top to bottom, right? So here we're saying that create job on streaming and from MySQL with a JDBC URL to that database demo native, so MySQL database. The offset initial line means that same two-phase behavior you watch Flink perform, or snapshot everything first and then follow the bin log forever. And then every table gets auto-created on the Doris side through this as a merge on write table keyed on the MySQL primary key, right? And that Doris CDC user is the part 2 clue that I mentioned before. Its grants are identical to the Flink's user because under the hood, this feature embeds the Flink CDC. So part 1 isn't getting thrown away, it's just moving inside the engine so you don't have to pre-assemble it all yourself, which is just a lot of headache and overhead completely removed. And then even the driver URL is a line is a callback as well. No Apache project can ship the GPL MySQL driver, right? That didn't change. The difference is that Doris fetches the jar from a URL for you instead of making you bake a different Docker image around it. So now if we reopen terminal here, so now if I run make native CDC, which is just going to start that script, and then run make native status, which is just going to go then and monitor it, you can see now I have my script up and running. Right, and so even though there's no data for consumption, right, it's going to now every time start doing that CDC motion. So going back into our dashboard up here, so here we're now going to start seeing our actual CDC in action, right? So now, if we also run docker compose ps and count the containers, there's nothing new started, right? Part 1, the pipeline with a job manager, a task manager, and a submit container, and 2 connector jars. And here, the pipeline is just a row in a system table. And also, that max interval that we set, right, set to 1 second in this job and file paces the job's commit cycle. So it's this statements version of the sync buffer flush interval line from chapter 3, right? It's that same kind of knob that we're using here, right? So just make sure you take note of that. This max interval there is essentially the same thing, and with it the sync is going to land in that same 1 to 3 second window that you saw in part 1. So then if we also run make native dash and flip the dashboard to demo native, so here native dash, then what we can do is go and open our dashboard. So it's going to recreate our dashboard with our make native, right? So here we can just refresh this page here. And you'll see now we have this new fresh dashboard, right, which is going to, it's the same dashboard, the same heartbeat trick, and now the latency tile will read 1, 2, 3 seconds right where Flink was. Updates flip, canceled orders vanish, merge on write does what it did all episode, and nothing stopped me from leaving Flink running, right? It's one bin log with 2 live copies, demo and demo native, that are just sitting side by side within that same warehouse. And it's the other thing I can vouch for is because having me been recording is Docker can restart on this demo, taking every container down, and the native job, as you saw right when I just refreshed the screen, it's able to come back on its own running and show that, hey, is this lagging, is this on, because it isn't infrastructure, it's just warehouse metadata, and it'll restart with the warehouse. And then there's also a single table variant of the same feature that can add exactly one semantics, column mappings, and transforms on the way in for mirror my OLTP database into the warehouse, which is most of what CDC is used for. So for that, the statement on screen is that whole job there, right? So again, just going back to our file, right, is just literally we're doing all of that again just with this with our native CDC job, and under the hood, Doris is really doing all that heavy lifting. So we talked a lot about having agents that are actually going to be running your pipelines, but what about agent skills that are going to be actually letting agents become the database administrators of today, right? Because they're not just the new heaviest readers. And VeloDB actually ships 3 open source skills through Apache 2.0 that plug into Claude Code, Cursor, Windsurf, any other kind of coding tool you're using. And they are, so you have first VeloDB Architecture Advisor, which can design workflow classification, data model choice, DDL generation, VeloDB best practices, which validates and diagnoses things like 37 DDL rules and real query profile analysis instead of guessing. And then you have VeloCLI Cloud that operates VeloDB Cloud with confirmation gates before anything can even mutate, right? So if I go and run make skills, my coding agent, really what I'm running under the hood is just, and I'll going back into my terminal here. So here, all you need to do is just go to npx skills add and then VeloDB/agent skills, and then this will install your skills locally, and you just go through this installer CLI to set them up so they're available for all of your agents on your own local machine. So once you're done with your installer, you'll see a message like this, and it's installed in all your coding agents. And now I'm going to show how we can actually use this in Claude Code to actually do some analysis with these agents. So here, just open up Claude. And then I'm going to make this request for, hey, review the DDL of demo orders in my local Doris against best practices and propose a partitioning scheme for my demo's order history, right? You can see immediately it's using that VeloDB best practices skill, right, to go and do that for me and actually go and use the CLI, figure out what the DDL is, and give me a real scheme that's based on my real information, but following the best practices so it makes the best use of Doris and all the great capabilities that are built in. So here, what it's going to end up doing is, reading the actual schema over that MySQL protocol and then grading it against that rule set. So we'll check back here in a second once it's done. So boom, now we have some suggestions on how to actually improve this score. And you can see that, hey, we have these different kind of, findings that we got through that skill operated by Claude. So now let's say, hey, I want to pull a query profile for the dashboard's top products query and tell me what's going to make this actually faster here, right? Let's actually close this loop, put some of those learnings into practice. And so for here, we're going to, find that, and then it's going to capture its profile from Doris, right? Agents that will fan all queries against the warehouse, and then they're also agents will tune the warehouse that you're querying, right? And so now the database becomes something your agents operate, not something that you actually babysit. So I'll give it a sec to show you the recommendations, and then we can wrap up here. And boom, now we have the real kind of understanding of, hey, collected statistics, and gave me some real actual actionable feedback of how I can start, updating and fixing and tuning my warehouse. So again, database is something your agents operate instead of something you have to babysit. So just to kind of summarize, the whole episode is, hey, you have a Binlog already that you almost certainly already have that feeds a CDC engine, right? Flink, if you want open source every knob, or since Doris 4.1, you actually don't need an engine at all because the warehouse can tail the Binlog itself. Either way, though, the data is queryable in seconds with updates and deletes handled by merge on write, and the dashboard proves the numbers on the screen. 1 to 3 second ingestion on both roads, agents that can burst like the one in the cold open with all 36 queries under 100 milliseconds, and 200 queries per second sustained on a laptop without a single error. And the agent skills mean the warehouse's own tuning is becoming agent work too. So if you want to check this out for yourself, I'm going to drop a link to Apache Doris in the description, and have a great rest of your day. Data Guy out.